Can I right mouse click? I can't. Rats. I don't even know how to do that. So what I can do is I can X out of here. Cancel. Where is our guy here? There you go. I want to delete this. I'm going to go ahead. Can I do that and delete it? We're learning something new. Delete. Should it remove? Yes. Hey, it worked. Great. I want to put the position on top of the time. Please do that. And it's doing this, okay? So now we know that something's up, so I'm going to delete that. Yes, another way to do this is to right mouse click on time, and as soon as I get this done here, I believe I can go ahead and, can I click on it? I can click on it. So left click, it's time, I want to change it to position. Okay, so it took a while to do that, but it looks as if dragging velocity onto the time axis didn't work. Not sure why, but here you go. So another way to do it is to just click on it and change it. I will update the instructions. So we have force versus position, and we have velocity versus position. Oh my gosh, fantastic. Oh no, not again. Create a third graph with acceleration versus position. Okay, let's do that. So here comes acceleration. Here comes anywhere. There we go. And change this to not time. Hello. Change this not time, but position again. There we go. So now we have all three of them. We have force versus position, velocity versus position, and acceleration versus position. That's fantastic. Wonderful. Double click. I did that. Click on the third tab. Double click on any white space of the force versus position graph. Okay. Up here, double click to bring up this guy. Wonderful. Bring up the graph inbox. Click on the third tab, axis settings. Okay, 1, 2, 3, axis settings. Excellent. In the automatic scaling selection, remove the check next to adjust axis to fit data checkbox. Okay, so adjust axis to fit data, remove that and say okay. Great. Okay, that was nice. Okay, at this point, the data has been set up. We are good to go. We have force versus position, we have velocity versus position, and we have acceleration versus position. Okay, cool. So what are we supposed to do? Move the collision cart toward the pulley so that the mass hanger is resting on the floor. Verify there is no force pulling on the force sensor before the next step. Okay, great. So what I want to do is I want to bring this so that it's resting on the floor, and then make sure there's nothing on the sensor, and then press the tear button. Again, this is how we zero this. There's the tear button. So I'm going to go ahead and press the tear button. It's back here. I can feel it. Click, click, click. And go ahead and drape this back over again. Fabulous. This tear is only performed once at the beginning of the entire experiment. Don't even think about pressing it again. I shall not think about pressing it ever again. Sorry. Place a 20 kilogram, or I said kilogram. 20 kilograms is huge. This is 1 kilogram. Wow, those are my bars. Place a 20 gram mass on the mass hanger. Let's see what we got here. Yeah, I was right. I need a 20. So this guy is a 20. It says right there 20. Go ahead and put that on the mass hanger. I'm going to lift this guy up. I already messed it up. Put a 20 on there. Great. Lay this guy back down again. Fabulous. Drape it over the pulley. Have done so. Excellent. Pull the collision cart back to the starting position recorded in step 1, which was way back here. Okay, so I'm just looking at that guy while I'm moving it back to make sure this guy is not swinging too terribly nasty. There we go. And I said we were going to start somewhere around 95, which is that guy. There we go. Cool. 95. Excellent. All right, I gotta get all this stuff out of the way because I don't want my my sensor to see that. Here we go. Excellent. Have one of your lab partners. I don't have any lab partners. It's not this semester. Place their hand in front of the bumper. Yeah, I have the magnetic bumper, so it won't crash too terribly. Press the start button and then release the cart. You do not need to press the stop button. It will stop collecting automatically. Okay, let's see if it works. So over here is the start button, way over there. Let me move this over here with my left hand. Okay, so you'll see that nothing's happening right now. Here's some data but no one's going anywhere because it hasn't passed the start position, which was 100. So then go ahead and let this fly. So I'm going to, well, the next time I'll watch the screen, this time I'm going to watch the cart. So I believe, because there's a little bit of tug there, this is going to accelerate my cart from rest, and then it's going to go down there. The weight is going to hit the ground, and eventually it's going to hit the bar on the end. So here we go. Fabulous. That was lovely. And hey, it worked. Here we go. Here's our data. It started and it stopped. Thank you, automatic computer. That's fabulous. We got some data here, a little tiny purple data, which is the force. It's a little bit negative. If I go ahead and where did it go? You'll notice it's a little bit negative as soon as I do this right. Come here, you can do this. It's a little bit negative because it's a pool. Notice it's kind of not straight. It looks as if this this guy over here seems to have unwound. And maybe that will, yeah, see how it unwound? As it did this, it came down here and then it unwound there. That's fine. We're just taking some data and we're getting an average, so nothing too huge. Okay, press the start button. Examine the data on all three graphs. Zoom in on the velocity and acceleration graphs and make sure that you have collected smooth data. Okay, so here's this guy. If I press the zoom button, which is this guy, and I zoom in on that guy, actually I take that back. That was this is the zoom button. If I zoom on this guy and look at this guy, it zooms in. There you go. So that's nice and smooth. That's the velocity. This is nice and smooth. And that is acceleration. If I push this button, I can go ahead and put this guy. Again, the acceleration is a little bit of jittery through here, but at least again, as it averages, it'll look pretty nice. That's a nice acceleration. Again, the acceleration should be, we expect it to be perfectly straight. But you'll see just the force changed a little bit too as its umbilical was unwinding. But hey, what are you going to do? Gotcha. Wonderful. All right. Once you have collected the smooth run, place an additional 20-gram mass on the mass hanger for a total of 40 and do it again. Okay, great. So we want to do this a couple times. I want to take a second 20 gram, and I now want to go from 20 grams of mass on my hanger to 40. Again, 20 plus 5 was 25, and now we have 45. There is definitely, I can feel definitely there's a force pulling this thing down. I'm going to let my string here go down nice and easily. Drape over this guy. Wonderful. All right, I come over here, and now I can back this thing up nice and easily the whole way back to the beginning again. It's hard to tell that there's a little bit of extra force on there, and I haven't reset the force sensor, so that's cool. Back a little bit. Again, I'm going to start at 95, which is this guy, because it's going to start at 100. All right, get this guy off the value here, and do this one more time. So I'm going to leave the data there. I'm going to go ahead and press start. Okay, and again, nothing's happening until I go. And then I let her fly, and this time I'll watch it. Okay, and again, pretty nice crash. Maybe that's why it suggested that I not have a lab partner help me with that. But yeah, so here's our second data. We can pretty much see that the second data, let's see here, where's our force at? Let me go ahead and see if I can't zoom this out here. Oh, look, okay, so here's run 1, which was this purple up here. If we were to zoom in very, very inside there, we would see that they're upside down triangles, but they're purple. So this was the first force. It is small, somewhere around 0.2 or negative 0.2, it's a pool. And then we about doubled the force. Again, we went from 25 to 45 because the plastic's 5. We got a larger force. A larger force caused a greater velocity. That's true. And it also caused or resulted in a greater acceleration. Fantastic. So run 1, run 2 for both of these guys. Fantastic. All right, so our last run, we are almost finished, guys, is to remove the two 20-gram masses and replace it with a 50. So what we're doing is we did 20, then we did 40, and now we're going to do 50. Okay, so I'm going to take these two, make those guys go away. This is a 50. Fantastic. This thing is really going to bump when it does this. So what I'm going to do is I'm going to I'm going to do what it suggests because I don't want my machine here to crash too terribly and fall off and really get messed up. So I'm going to move this guy back, okay? Starting at 95 again. I'm going to bring over the mouse. And then what I'm going to do is I'm going to hold it with my finger. I'm going to press start, and since I don't need to press stop, I am going to put my finger here and sacrifice my finger and catch it. I don't want it to crash. All right, so here we go, way over there. I'm going to press start. I don't need to do anything until I let go. I'm going to put my fingers down here so it doesn't crash terribly, and then fly. Here we go. And it didn't feel that terribly. It was a much softer slam because it slammed into my fingers. Obviously, I didn't lose any fingers. It wasn't too terribly bad. But if I go back here and look at this data, what do we got here? Yeah, we have 3 runs. Run 1, run 2, run 3. Purple, blue, and red. Very nice. Purple is around 0.2. Blue is around 0.4, and red is somewhere around, well, 0.5, quite honestly. It's almost 2, 4, and 5. Almost like if gravity was 10 meters per second, the force on 20 grams would be about 20, 40, 50. That's pretty cool. We have the run 1 was this velocity. Run 2 is the red velocity, or this pink velocity. Red 3 is the green velocity. Down here, the acceleration is a little bit noisier than it was before, but it's still higher. It was green, and then it was purple, and then it was blue. And you can see it's sort of jumping around, but we're going to get an average value anyway, so that's cool. Fabulous. All right. Let's see here. Data collection is now complete. The next steps will permit you to analyze data. Great. Zoom in on the force versus position data. I shall do just that. So I'm going to go ahead and grab the zoom select button. I'm going to go ahead and zoom in on that guy. So there's my data. Fantastic. Press the down arrow and next to sigma button on the toolbar to drop down the statistics button and place a check mark next to mean. This will calculate the the average value for each run in the legend boxes of each graph. Okay. So I'm going to go ahead and pull this guy, press my sigma button, and I want mean. Oh, mean's already there. Wonderful. Great. So did I see it? Is it there? I click on. Oh, I don't have anything selected. I don't think. Run 1 and press this guy. There we go. I just didn't have anything selected. So min, max, mean. Okay. Min, max, mean for these guys, and min, max, mean for these guys. Wonderful. All right. Great. Go to the next page. At this point, the acceleration graph down here, what a prediction, may display NaN for not a number for the average value of 1 or more runs. This indicates that 1 or more of the data points in the acceleration data was not calculated, and it was calculated to be not a number. This happens when the program attempts to take the slope of a slope values of position to calculate acceleration and the position data and divides by 0. Okay, so it didn't destroy the calculator. It just says, oh, I can't divide by 0. The slope of a slope, rise over run, rise divided by run. So we need to fix that. Okay, so what we're going to do is we're going to click and drag the acceleration entry with the graph icon next to it in the bottom section of the data list for run 1, run 2, and run 3, whichever run has a NaN value, down to the table icon under the displays section. Okay, so let's do that. So over here under data, we have all this data running around. We have 3 pieces of data for all these values. We have force, channel A, run 1, run 2, run 3. We have position, run 1, 1, 2, 3, and velocity and acceleration. And then down here, we have force, channel. Oh, this is the graphs, okay? So this is the force graph. So what we want to do is this is the sensor data, and this is the run data, okay? That's what we want to do. Click and drag acceleration, channel 1, channel 2 entry with the graph icon next to it. Yep. So there's 3 graph icons. This is the data that has been plotted. So it looks like run 2 of acceleration and run 3 of acceleration need to be changed a little bit. We need to get rid of those not a numbers, okay? So pull this down to the table icon. Let's do that. So here's the table icon down here. I want to go ahead and grab acceleration run 2, which is this first guy. Grab that, click and drag, and drop it on the table. There's our table. Okay, and you'll notice that these first 2 up here, this first run and the second run, they have been calculated to be not a number. Okay, great. Not great, but we're going to fix it. Press the pencil icon on the toolbar to switch to edit mode. Alrighty. I'm going to go ahead and press the edit mode. Fantastic. Should data make a yes, please? Say OK. Should data change under displays? Yes. We want to use the edited data. Great. And what we're going to do is edit the values of the acceleration that currently have a value. Replace the NAM with the first not a number value appearing in the table. Okay, so you'll notice that these guys are mostly 0.4, 0.4, 0.4, 0.4. So what we're going to do, we're going to change this to 0.4. We're not lying, we're just changing it to 0.4. And we're going to change this guy to 0.4. 0.4. Fabulous. Okay. So now, just like all these collections here are all 0.4s, the first two are also 0.4s. It just happens to be an artifact of how it calculated the answer, and it divided by 0 rather than getting 0.4 because of the noise. Minimize this table. Do not remove the data. Okay, so go ahead and do that. And when I do that, you'll notice that now this guy edited has been fixed. Okay, so now we have a real value, and of course it was 0.4. We need to do the same thing for run 3 under the acceleration. Here's run 3, and we have a run 2 edited. Notice there's a pencil icon saying that we have it, so everything is out in the open. We're not trying to hide anything. I'm going to create another table, and this table has, again, 2 ones down here. These guys are all over the place. There's 0.8, 0.2, 0.5, 0.1, 0.9, 0.5. This is me editing the data on the fly. It looks like the most, the median, the one that appears the most often is 0.5. So I'm going to change this not a number to 0.5. I need to edit and say OK. And you bet. And go here. Oh, sorry, go here. And put in 0.5. That seems to be the one that occurs the most. 0.5. I said median. I should have said mode. And then minimize this guy, and it's fixed it as well. Pretty obvious that the mean is 0.5. We have data. Fabulous. All right, move this guy over here. Now that the erroneous not a number calculations have been corrected, you can use the average values from each data run to complete the chart below. Okay, cool. So let's go ahead and do that. The mass on the hanger for run 1 was 20 grams. All right. The mass on the hanger for run 2 was 20. Strike that. This is why was 40 grams. It was a mistake. And then this guy is 50 grams, mass on hanger. The average force, I need these 3 values, 1, 2, 3. I'm going to look at them. They are negative